Hey, welcome. Nice to see you there. Thanks for visiting Sa Majesty Easy World Science Channel today. I will take a look at this. I just concluded NECO chemistry exams. I'll go with the objective questions. Then that's 2021 NECO chemistry, National Examination Council Nigeria. I'll go with the objective and I'll be as fast as possible. Then you see the theory answers coming in another video altogether. So here, let's gradually lift the questions. Okay. Okay, so here we have question number one, which says an increase in the pressure of a gas results in the decrease in its volume. That's option E. Simple. That is your, remember your Boyle's law that volume varies inversely with pressure, and the pressure also varies inversely with volume. The number two says during the extraction of iron, limestone combines with acidic impurities in the blast furnace to form slag. So next one, number three says 12 grams of water is saturated with 15 grams of potassium chloride at 20. Calculate the solubility of potassium chloride. Simple. We just say since 12 grams, we're able to dissolve 15 grams. What will 1000 grams dissolve? That's the solubility. And we have automatically, maybe I think the pen is visible enough. So that we have 15 over 12 times 1000 over 1. From the calculator department, you have 15 times 1000, then divide by 12 will give you 1.2, okay, 1250 grams per dm cube. Then find the molar mass of potassium chloride, which will give you 39 plus 35.5, 74. So we're going to say 1250 divided by 74.5, which will give you 16.8. So that's it. Then the next question says a plastic which cannot be softened by heat is called a thermoset, while thermoplastic can be remolded and remelted. So you can recycle thermoplast, not thermosets. The reaction between alkanoic acid and alkanols in the presence of mineral acid is called esterification. The reaction between the sodium hydroxide solution and nitrogen 4 oxide gives you this. Will write the equation of the reaction: sodium hydroxide plus NO2 will give you, because this NO2 is a double anhydride, it's an anhydride of two acids, of course, it will give you the nitrate 3 and also give you the dioxo nitrate 5, which are beaten, then plus water. So here is 2 and here is H2O. So that's the thing formed, which means the products are NaNO3, NaNO2 and H2O. Which option have that? That's option E, water, NaNO2 and NaNO3. So question 7 says consider the reaction represented by the equation below. Then which of the following, remember they give us heat change. Heat change is negative, meaning it's an exothermic reaction. Which of the following takes place when the temperature of the reaction vessel decreases? If this is exothermic, it means that decrease in temperature will favor the forward reaction, and forward reaction is the formation of hydrogen iodide. So let's say more of the hydrogen iodide decomposes. No, that is backward reaction. B says the concentration of the reactants remains constant. No, the gases condense. Then option D says the yield of hydrogen increases. It's not true. Then E says the yield of hydrogen iodide increases. Yes, because the equilibrium position will shift to the right, favoring more hydrogen iodide. So the next question, number 8, says which role does sodium chloride play in a soap preparation? Sodium chloride is used for salting out. Acceleration? No. Convert the fatty acid to sodium salt? No. Purify the soap? No. React with that. Now option E, separates the soap from the glycerol. Yes, that's what we call salting out. Okay, so I think I gotta clean off. Okay, so the answer to this is E. Chemical change includes the following except the composition of green leaves in a compost, yes, is a chemical change. The solution of sugar in water is not a chemical change, it's a physical change. Fading of color of cloth, chemical. Fermentation of glucose, chemical. Rusting of iron is a chemical change. C, don't confuse you. Color change of cloth is a pure chemical reaction because it's all about reducing agents and oxidizing agent reacting, leading to color changes. Okay, so we take a look at the next question. Go to the next page. Okay, this is far from it. Okay, this is question 10. This is probably where we'll continue. Given that 32 grams of sulfur contains 6.02 times 10 to the 23 atoms, how many atoms are there in 2.7 grams of aluminium? Simple. I'm looking at the answer here without solving. It's supposed to be B, but I'll solve to show why and how. So in this aspect, what you need to do is remember that sulfur is 32. It was given to you in grams, which means 32 grams of sulfur represents 1 mole of sulfur, and aluminium is 27. Then 2.7 grams of aluminium is 0.1 mole. So it means that if 1 mole contains this 6.02 times 10 to the 23, 0.1 mole will contain exactly B. So just convert the masses to mole, and remember that equal moles have equal particles. That is Avogadro's hypothesis for you. Then which of the following elements is diatomic? Argon is monatomic, carbon, no, iron, no, oxygen, yeah, it's a bonus question. So oxygen. Then the chemical process that is represented by the equation below is sodium trioxo carbonate 4 decahydrate changing to sodium trioxo carbonate 4 monohydrate and 9 water. That is what we call efflorescent. It lost water of crystallization. I think I go with this blue. So efflorescent, then remember that's loss of water of crystallization, and washing soda is sodium triisocarbonate 4 decahydrate. Exposure to atmosphere makes it lose 9 out of 10 of its water of crystallization. The type of chemical bond that exists between potassium and oxygen in potassium oxide is ionic or covalent, ionic or electrovalent, which is option D, is ionic. The elements in group 1 of the periodic table are called alkali metals, while group 2 are called alkali earth metals. An oxide XO2 has a vapor density of 32. What is the atomic mass of X? 32 times 2, which will give you 64. Remember that vapor density is equal to relative atomic mass divided by 2, or rather you say that relative atomic mass is equal to 2 times vapor density. So if vapor density is 32, 2 times 32 gives you the relative mass of X. Which of the following is not a normal salt? Option A is an acid salt because it has hydrogen, it's not properly neutralized. Then option 17 says the product of electrolysis of dilute sodium chloride solution with platinum electrodes is dilute sodium chloride solution will tell you, remember your activity series, sodium will not come out, chlorine will not come out because it's dilute. Therefore, we are looking at hydrogen and oxygen gas, which is option C. So we go to question number 18. Number 17 we said is hydrogen and the oxygen gas. Then question 18 is calculation. What current in amperes will deposit 2.7 grams of aluminium in 2 hours? So simple, you use Faraday's first law of electrolysis. To make it quicker for you, you just use you can watch my video here to know how I'm using this. So you can use the mass discharged is equal to Ramit over Chaffer, which means the mass was given, you put 2.7 there. Ramit means relative atomic mass of aluminium, which is 27, times current, which is what they are asking you, then times time in seconds, that is 2 hours, which is 2 times 60 times 60, divide by the charge on aluminium is 3, that's the charge here, then Fa is Faraday. 1 Faraday is 96,500. So at the end we have that current, you now make it the subject of the formula. Current should now be equal to 2.7 times 3 times 96,500 divide by, of course, divide by 27 times 2 times 60 times 60. So at the end we have that current is equal to, remember why I say 60 times 60, I'm converting the hour to minutes. So what do we have? We have 2.7 times 3 times what do we have there? 96,500, which will give you 781,650. Divide by 27 times 2 times 60 times 60, which will give you, so what we have here is 4.02, and the answer is A. So our answer is 4 amperes is what is required to get such mass in such time. Then the next question say a current of 4.0 amperes was passed through copper 2 tetraoxosulfate solution for 1 hour using copper electrodes. You still use that formula I use here, which is Ramit over Chaffer. So in this case you have that mass discharge equal to relative atomic mass, which is 64 of copper, times the current. The current is 4, then times time. The time is 1 hour, which is actually 60 times 60, which is 3,600. That's it, 60 times 60. Yes, then divide by the charge on copper. The charge on copper is 2 times 1 Faraday, which is 96,500. Remember in aluminium we use 3 because the charge in aluminium is 3. Okay, pressing this you have that 64 times 4 times 3,600 is equal to 92160 divided by 193,000. That's 2 times 1 Faraday. 193123 is 4.77, which is B, 4.8 approximately. So that's the answer. The next one says, which of the following is a basic salt? So this cheat I use is in case if you don't know how to do the normal calculation. This will save you time. That's Her Majesty's cheat. Mass discharge is equal to Ramit over Chaffer. That's relative atomic mass times current times time, all over charge on the ion times 1 Faraday. There are other cheats. Stay on here, I'll give it to you. Which of the following is a basic salt? Simple, that is B. B is a basic salt. That's magnesium hydroxide trioxonitrate 5 because it has OH. Acid salt have hydrogen, basic salt have OH in them. What percentage by mass of sodium is present in the compound Na2CO3? That's sodium triacylcarbonate decahydrate. Please bear this in mind. I already know the molar mass of this compound is 286. That's the total mass. Then there are 2 atoms of sodium and 1 sodium is 23. So 23 times 2 is 46. So we have 46 over 26. I may be using this. So we have that let me increase the thickness. Okay, we have here that 46 over 286 times 100 over 1. 46 over 286 times 100 over 1, that's 16.80. So the answer is C. Then number 22 says, I gotta remove this. In the extraction of iron, which of the following reaction does not take place in the blast furnace? The raw materials in blast furnace includes limestone, coke, and the iron ore itself, that's iron 3 oxide. So the limestone A occurs there to produce CO. Then the CaO combines with this to form the, so B is occurring, and this is what we call slag. Remember question number 2 here previously, that's what we call slag, calcium triazosilicate, remove that slag. Then the CO2 produced here will be used to oxidize the coke to CO. Then the CO will be used to reduce the iron. So the thing that do not occur is D. the coke don't directly reduce the iron 3 oxide, rather it is oxidized to carbon 2 oxide, which is also a reducing agent. So E occurs, D do not occur. The metal that can be extracted from cassiterite is an ore of tin, and cassiterite is also called tin stone, and the formula is tin 4 oxide. So the next question is over here. They said the hardest form of carbon is diamond. That's a bonus question. Then the other one says the ability of carbon atoms to form long chains or ring is known as catenation. Simple. That's the ability of carbon that enables it to form numerous organic compounds. Then an acid is a substance which in the presence of water produces the hydroxylum ion. According to Arrhenius acid is a species that will produce these two things in water, either this or this, hydroxylum ion or hydrogen ion as the only positive ion. So we go to question number 27. Okay, here we continue here. Question number 27 says a hydrocarbon X with a molar mass of 26 consists of 92.3% carbon. What is the molar mass? Sorry, what's the molecular formula? Okay, you just note this, please. Any 92.3% is only for alkynes. All alkynes have 92.3% carbon. Simple. And looking at this, and they say the molar mass is, don't solve this, don't just waste your time. Though after solve, you still get the answer. Since it's 26, watch this. C2H2, carbon is number 12. 12 times 2 give you 24 plus 2, 26. And they mentioned it here already. So next question says, the components of universal indicator solution can be separated by chromatography since it's colored. So chromatography is used to separate colored substances. Then, sulfur exists in different forms in the same physical state. This phenomenon is called allotropy. So existence of an element or a substance in the same physical state in different forms is called allotropy. Sulfur, carbon, and I think even tin, they all exhibit allotropy. Phosphorus also. Which of the following atoms contain the highest number of electrons in its outermost shell? Please, if you see noble gas apart from helium, that should be the answer. A is oxygen, and oxygen is 8. That's 2, 6. It has 6. Then B is argon, which is the answer. That's 288. That's correct, argon. Then this one have 5 in the outermost shell. This one have 1. That's 2881. Then this one have 2. So you get them by writing their configuration K, L, M, and N. For A is 26, for B is 288, that's 18. Then for C it is 285. Then for D it is 2881. So the last share is 1. For E it is 282. So the one with the highest share in the outermost share is actually the argon, which is 288. Okay, we go to question 31. How many grams of hydrogen will be liberated when 6 grams of magnesium ribbon dissolves in HCl? Write the equation. May looking at this, I have the cheat. It's going to be, how many times will you divide 24 to get 6? You divide it by 4, which means you divide 2 by 4, which will give you half. It's going to be B, but let me solve. Write the equation. You have Mg plus HCl will give you automatically MgCl2 plus hydrogen gas. Put 2 here and the equation is balanced. Therefore, they are comparing magnesium and hydrogen, which means 24 grams of magnesium will liberate 2 grams of hydrogen. Remember, don't use 1 here. Hydrogen is 1, of course, but times 2 is diatomic. Therefore, 6 grams will give you X. Cross multiply. 6 grams will give you automatically 2 over 24 times 6 over 1. Yes, of course. I'm correct. 2 over 24 times 6 over 1, such that we have 12 over 24, which will give you half. That's 0.5 that I suggested well. Okay, so the next one is a piece of damp litmus paper was dropped into a gas jar of an unknown gas. The litmus paper turned pink and then bleached. Simple. Turning it pink shows that it is acidic a bit. The gas is acidic for having an effect. Turning it pink means that it's blue already, and acids have the effect on blue litmus paper. Then bleaching it shows is a bleaching agent, and that's chlorine gas. Chlorine gas, when dissolved in water, forms an acid known as HOCl, oxochlorate 1 acid, and this HOCl is a bleaching agent, thereby removing the color entirely. So number 33 says an unknown gas with an irritating smell was bubbled through a solution containing acidified potassium heptachromate 6. The solution changed from orange to green, meaning a reducing agent. Option A is out, B out, C D, E can be the correct answer here, please. Hydrogen sulfide will do it, ammonia will also do it, then SO2 will do it. But let's go to the question. They say irritating smell. It's a bit confusing, but to my understanding, it's supposed to be SO2. But remember, hydrogen sulfide will also do the same because it's a reducing gas. Ammonia has a choking smell. Hydrogen sulfide have a smell of a rotten egg, repulsive, but I think SO2, from my experience, it has an irritating smell like that of burning matches. Then the major constituent of air is nitrogen, 78%. Imagine what has taken 78 has taken all. These are about 1%. Carbon dioxide 0.3%. Water vapor still low. After nitrogen becomes oxygen. So in the atmosphere, the most abundant is actually nitrogen, followed by oxygen, which is 20 to 25%. 35 says, which of the following pairs of halogens are gases at room temperature? Fluorine and chlorine are gases at room temperature, which is option B. You should note this group 7 element, you take it fluorine, chlorine, bromine, iodine, astatine. You can use the acronym Football Club Barcelona International astatine, Football Club Barcelona International astatine, or you say FCBIA. So in terms of state of matter, the first two here are gases at room temperature. This is a volatile liquid, then these two are solids. So that's it. And remember, in color, as you move down the group, their intensity of color increases. Fluorine is yellow, chlorine is greenish yellow, bromine is brownish, then this is about dark blue or even black, then astatine, AT, is also black. So we move on. Which of these compounds will not give oxygen gas on heating? Ammonium triazonitrate 5 will not give you oxygen gas on heating. Every other triazonitrate 5, apart from this ammonium triazonitrate 5, liberates oxygen on heating. And remember, heating ammonium nitrate, just like other nitrate, is dangerous, but that of ammonium nitrate is more dangerous, it's explosive, and that's how we prepare laughing gas in the lab. So don't be deceived. If you heat hydrogen peroxide, if spontaneously, even without heating, gives you oxygen. Manganese oxide is an oxidizing agent because it releases oxygen, of course, on heating. Sodium triazonitrate 5, of course, releases oxygen and dioxonitrate 3 of sodium. Then zinc triazonitrate 5 releases oxygen with zinc oxide and a reddish brown gas. So the answer is A. Please don't get it twisted. This is the formula NHNO3. Action of heat on this will automatically give you N2O, which is laughing gas plus water. And remember, this is explosive. You don't heat it direct. You mix up sodium triazonitrate 5 with ammonium chloride and get what you want. This is our laughing gas. If you put 2 here, the equation is balanced. Okay, when sodium dissolves in water, the resulting solution is alkaline. When sodium dissolves in water, it gives you alkaline because it forms sodium hydroxide. It's a chemical change. It will give you sodium hydroxide plus hydrogen gas, and this is alkaline. The oxidation state of chlorine in this compound is 5. You can use your eye and find it even without calculation. Watch it. If you have KClO3, anytime you see oxygen, remember that oxygen is -2, therefore -2 times 3 is equal to -6. So if you see -x class, please look for +x, because +x minus x will give you 0. So we have seen -6, so we are looking for +6. These two compounds behind oxygen are going to provide this 6. It's obvious that potassium is providing 1. So we are looking for 6 and potassium have provided 1. Automatically chlorine will provide 5. So that's a cheat, but if you don't know how to get it, just say potassium is already. So we got this there. Okay. Let me just solve for the normal strategy. The normal way of solving it. We have 1, that's for, oh my god, potassium is 1 times 1 plus Cl plus -2 times 3, which is equal to 0, so that 1 plus Cl minus 6 is equal to 0. 1 plus Cl is equal to 0 plus 6, such that Cl is equal to 0 plus 6 minus 1, so that Cl is equal to +5. So, but with that cheat, I thought you can get the answer without wasting time. Okay, group 0 elements are unreactive because their highest energy level is fully occupied. Very correct. That's why they are unreactive. They have attained stability, and the two types we have is octet or duplet stability. Helium is the only one that have attained duplet stability among them. Every other member have octet stability. Question first, it says, what type of bond will be formed when an element with high electron affinity combines with another element with low ionization energy? Let's be careful here. High electron affinity means that particular element can easily accept electron. Then low ionization energy means that you can easily knock out electron from that element, which means this is a combination between non-metal, that's those ones that have high electron affinity actually non-metallic, those with low ionization energy are actually metals, therefore is electrovalent. So electrovalent combination, electrovalent bond is the answer. An atom X with the electronic configuration 1s2, 2s2, 2p6, 3s1 belongs to the period. Simple. Please, this is a cheat I'm giving you. If S ends a configuration, for now, apart from helium, use this cheat. If S ends a configuration, do you see this? What ended it is 3s1. With this, you can predict your group and period. Automatically, this one is the group. Here is the block. And here is the period. So it is in period 3. I know some of you will now count 2 plus 2, which give you sodium, and now go back and do it. You might waste your time. Just find this cheat, which means you use this I taught you and try any other element. If S ends it, so that is only when this is true. If S do not end it, watch my videos here, or you can book for your own private classes so that I can give you easy cheats on how to answer this question without wasting time. Your fellow student will use the solving, you look at the thing and answer it. So the answer is there already. So which of the following methods is suitable for separating petroleum fractions from crude oil? It's simple, fractional distillation. Why? They are miscible and they have different boiling points, and they are good enough to be separated by that method. The process involved in the decomposition of sugar by an enzyme. If sugar is decomposed by an enzyme, no. Dehydration, no. And yeah, it's going to be called fermentation. So we go to question number 44. Question number 44. Not here. Not here still. What's happening? Question 44. Is it that I didn't lift it? Okay, here we go. Question 44. An organic compound which reacts readily with bromine to form a compound with the formula. You know, bromine, this has formed a saturated compound, and how many carbons are there? 1, 2, 3. So we have prop. Okay, we have 3 things that are prop, but because of the fact that it only took 1 atom of bromine, they say an organic compound which reacts readily with bromine to form this is a substitution reaction. Yes, of course, this is what we call a halogenation. Yes, on drawing this compound we have this such that what will be here is hydrogen, 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 hydrogen. Then what's supposed to be here initially is hydrogen, but bromine now substituted. So an substitution reaction, if it were to be, let's just check, an organic compound which reacts readily with bromine to form, of course, it's propane, because if it is propane, it's going to form, its addition reaction is going to form either 2,2-dibromo propane, or not just 2-bromopropane. No, for accepting only this one, that's substitution reaction, which means what will be formed alongside is also HBl. So please, it should be propane. Okay, that's option C. Water from a river contaminated by alkali waste. We have a pH. This is alkali waste, have a pH about 9, since it's alkali, because above 7 is alkali. Which of the following mathematical representation is for Graham's law? Okay, R1 over R2, yeah, is correct. R1 over, option A is correct. Option B is incorrect. Option C is also correct. So there are 2 correct answers here. That's the problem. He who said this question never knows science. Please go everywhere you are in science. Option A and B and C are the same thing. They never knew. Please, if a student should write this for you, that's Graham's law. This one is also Graham's, but they are memorizing. They think that this formula and this one will give you the same answer. Let me just prove something here. Option D says R2 over, okay, wrong. E says R1 over this. No, wrong. Stay. But A and C is very correct. This is the problem we face. They will now go and mark someone that writes C wrong, but C is still correct formula. If, for example, you have that, watch this. If 2 over 4, which we all believe is true, is equal to 10 over 20. We all believe this is true. Watch me. I want to invert it, which means R1 over R2 is equal to square root of D2 over D1. But what if I bring R1 down and take R2 up, which is what happened here? Then this one was taken up also. It will give you the same answer. Oh yeah, let me invert here. It becomes 4 over 2 is also equal to 20 over 10, which is correct. 4 over 2 is half. 10 over 20 is still half. Then 4 over 2 is nothing but 2. Then 10 over 20 is nothing but 2. So A and C are correct correct way of representing Grahams. That's it. Nobody is perfect, but if they give chance, we might contribute for them. But Trust Africa, they don't want that. They think that criticism shows they are bad. No, criticism is a way to be perfect. Just like you watching, you feel free to criticize me also, constructively, not destructively. Then remember to book for your own private classes. You chat me on that number you see on the screen. Then we go to 47. The density of a certain gas is 2.0 gram per dm cube at STP. What is the molar mass of the gas in grams? Simple. Density, meaning this gram per dm cube, means that 1 dm cube of that gas automatically have a mass of 2.0, because they say per dm cube. Then molar mass of a gas is the mass occupied by 22.4 dm cube, will give you X. So me looking at this, how many times do you multiply 1? This was multiplied 22.4 times, so you also multiply this 2 times 22.4 will give you 44.8. That's the answer. But let me still cross multiply for the low thinking ones. This should be X equal to 22.4 times 2, which is 44.8. According to Charles' law, the volume of a gas becomes zero at minus 273 degrees. Yes. A brown ring test indicates the presence. Watch my video here on brown ring test. Of course, it indicates the presence of nitrate 5 ion. The final product of the reaction between C2H5OH and excess concentrated H2SO4 at 170 degrees. The H2SO4 will dehydrate the ethanol, and that will leave us with ethene. Remember, C2H5OH is the ethanol. Then treating it with concentrated in excess H2SO4. The H2SO4 will just remove. The H2SO4 will just remove the water. I think I have to reduce the. Do I need to adjust my pen? Come here. What can be adjusted about this pen? Nothing. Okay, maybe. Okay, now if you do this, the H2SO4 will just say minus H2. Remove water here. Remove 2 hydrogens. There are 6 hydrogens. Carbon is constant. This is 5 plus 1, 6. Then if you remove 2, there it remains 4. There is only 1 oxygen and it has been removed. So what remains is ethene. Okay, we go to question 51. Which gas is evolved when alkanols react with sodium? Hydrogen gas. Simple. Together with the formation of sodium ethoxide. The way sodium reacts with water is the similar way it reacts with ethanol. Burette test is carried out on organic compounds to determine the presence of protein. Watch my video here, especially in biology for food tests. Hydrogen is used for the following except conversion of coal to petrol. Yes, that can be possible. Extinguish fire. Never. You can never use hydrogen, which is combustible, to extinguish fire. Rather, it will support fire well. It will burn well because it's combustible, though itself doesn't support combustion but burns. When a solid substance disappears completely as a gas on heating, the substance is said to have undergone sublimation. Whenever liquid state is kept, you call it sublimation. Then 55 says the shape of ammonia molecule is trigonal pyramidal. So linear is for CO2. Remember, octahedra is for diamond, of course. So tetrahedra is a tetrahedra. I think diamond is tetrahedra, but octahedra is for the shape of other sulfur. Okay, the metal that is used as a catalyst in the hydrogenation of oils should be nickel catalyst. That's conversion of oil to fat. The position of an element in the periodic table is determined by its atomic number, which is also the number of protons. Atomic number means, so option D is correct. The following are uses of ammonia except A, as a precipitating agent, B, in the production of margarine, not too sure, production of plastics, refrigeration, D, correct, in treating insect bites, maybe because it's alkaline in nature, it might be used. 58, honestly, I think, okay, let's use the elimination method. A is correct. Not sure about B, not sure about C. D and E might be correct. So the answer lies between B and C. Please find out. I wouldn't answer what I'm not sure of. This question is confusing to me. I know that ammonia is a precipitating agent. Use it as refrigeration, yes, of course. But being basic, it might be used to treat insect bites that are acidic. I wouldn't know if we use it in plastic. We might use it in plastic. Margarine, I don't think. Please, we should take this one. I don't think ammonia is used in manufacture of margarine. I'm taking B from my elimination method. Then we check the last one of these questions. Okay. Let me check my... No. Okay, I think I have it here. So let me complete the thing from here. Okay. I hope it can be clearly seen. Zoom in. They say what quantity of current in amperes will deposit 5.4 grams of aluminium in 8 hours during electrolysis. You still use Grammet over chapter I taught you. So here 5.4 grams of aluminium in 8 hours during electrolysis. So you still use that cheat 5. In 8 hours. So we memorize 5.4 and 8 hours. Okay, I think let me answer it direct. 5.4 in 8 hours. So we have mass discharged is equal to, and the mass given was 5.4. And 27 is the latest atomic mass. The current was what they are asking for. The time is 8 hours, which is 8 times 60 times 60. Divided by charge on aluminium is 3 times 1 Faraday, 96,500. It's the easiest cheat to get what we want. So what we have, current is equal to 5.4 times 3 times 96,500 divided by 27 times 8 times 60 times 60. Press stretch, we have that 5.4 times 3 times 96,500. We got that we have 156,300 divided by all together. We'll press stretch 27 times 8 times 60 times 60, which will give me 2.0. So automatically we have 2.0 grams. So not grams, amperes actually, because they asked us current, which is measured in amperes. So go back to the question. I think I have to shift this to that my file. Okay, bringing this, we have 2 there. So the correct answer there is actually A. So the last but not the least question. Clean up this so that you can see well. Okay, so the volume of a gas at 310 Kelvin was 200 cm cube. Determine its temperature in Kelvin if the volume becomes 250. So volume and temperature, if the volume, they gave us volume and temperature, which means pressure is constant. That's Charles' law. Can we predict the answer? Yes. In Charles' law, it says that when temperature increases, volume increases. So the 3K gave us 200. Then when it becomes 250, the temperature will be above 310. So how many options are above 310? Only 2 options. And I'm thinking that D is correct. But let's solve. D is supposed to be the correct answer. Okay, using V1 T1 equal to V2 T2. Our V1 is 200 divided by 310 equal to 250 over T2, which is unknown, such that T2 in this condition will now be Simple. T2 here will be 250 times 310 divided by 200. So 250 times 310 divided by 200 is 380. Okay, this is the answer, please. 388. Okay, that's it for the objective. Now for the theory, you check for another video. That's where I will handle the theory questions, and it has started. Thanks for being there. Her Majesty's World Science channel is good. Remember to share my videos and also book for your own private classes for yourself, for your students if you're a teacher, and also for your child if you're a guardian or a parent. I love you. Thank you for watching. And